Neutron stars are some of the most extreme objects in the universe, packing more mass than the Sun into a sphere just 10 to 15 kilometers wide. These remnants of supernova explosions are incredibly dense, with gravity so intense that it warps space-time around them. But what truly makes neutron stars fascinating is what happens at the quantum level inside them. From superfluid neutrons to quark matter and even color superconductivity, neutron stars may hold the key to understanding the most extreme states of matter and even provide insights into the fundamental forces that govern the universe. Could they be the missing link between quantum mechanics and general relativity? Neutron stars are born from the death of massive stars, at least 8 to 30 times the mass of the Sun. When these stars run out of fuel, their outer layers explode in a supernova, while the core collapses inward under extreme pressure. This compression forces protons and electrons to merge, forming neutrons in a process called electron capture. The result is a star made almost entirely of neutrons, governed by quantum degeneracy pressure, which prevents it from collapsing further. The density inside a neutron star is so high that a sugar cube-sized piece of neutron star material would weigh as much as a mountain on Earth. Some neutron stars, called pulsars, rotate at incredible speeds, up to 700 times per second, and emit beams of electromagnetic radiation, acting like cosmic lighthouses. But while neutron stars appear stable from the outside, their interiors are anything but ordinary. As we go deeper, we enter a realm dominated by quantum physics. The outer crust consists of superdense atomic nuclei, but deeper inside, even atoms cease to exist due to extreme pressure. Electrons are squeezed into protons, forming a sea of pure neutrons. This matter behaves in a completely different way than anything we see on Earth. At a certain depth, neutrons may enter a state of superfluidity, where they move without resistance, like liquid helium in laboratory experiments. This could explain why some pulsars suddenly change their spin rate. Scientists believe these glitches occur when the neutron superfluid inside shifts, transferring energy outward. But the strangest part? If the pressure inside a neutron star is high enough, neutrons may break down into their fundamental building blocks, quarks. This would create a quark-gluon plasma, the same ultra-hot state of matter that existed in the first microseconds after the Big Bang. If this happens, the neutron star might actually become a quark star, an entirely new type of celestial body. Some scientists even suggest that quarks inside neutron stars could form color superconductors, an exotic state of matter where quarks pair up similarly to electrons in a superconductor. If true, this would be a never-before-seen phase of matter that could revolutionize our understanding of physics. Since neutron stars are incredibly small and distant, studying them is a challenge. Scientists rely on X-ray telescopes like NASA's NICA, gravitational wave detectors like LIGO, and other space observatories to analyze their properties. One of the most exciting discoveries came in 2017, when astronomers detected gravitational waves from a neutron star merger. This event not only confirmed that neutron stars create heavy elements like gold and platinum, but also provided new insights into their mysterious interiors. Neutron stars serve as natural laboratories where we can test the limits of quantum physics, nuclear physics, and general relativity, all in one place. Future space missions, such as the Laser Interferometer Space Antenna, LISA, and advanced neutron star simulations, may help reveal whether quark stars, superfluid neutron cores, or even new forms of matter really exist. Could neutron stars hold the key to unifying quantum mechanics and gravity? The deeper we explore, the more these cosmic enigmas challenge everything we thought we knew about the universe. What do you think? Could neutron stars unlock the deepest secrets of physics? Let us know in the comments, and don't forget to like, share, and subscribe for more mind-blowing space science content.